All right, guys, welcome to the Measures of Variation, Chapter 11, Section 4. What is the measures of variation? Well, the measures of variation is used to determine how consistent the data set is with the other members in the data set. The higher the measure of variation, the less consistent the data set is, perhaps more unreliable. So, as I said before, when it came to the measures of averages, which we call the measures of central tendency, when the mean, median, and mode are approximately the same, that means we can consider our data set to be normally distributed, symmetrical, which indicates that a large cluster of my data values center around the middle. They are consistent overall. The measures of variation determines the over consistency within the numbers themselves. Now, there are three types of measures of variation. There's the range, the variance, and what is called the standard deviation, things you will be seeing in Stats 250. The range is the simplest of the three measures of variation that we will study. And the range is pretty simple. The range of a data set is the difference between the highest value and the lowest value in your data set. Pretty straightforward. And the formula to find the range is listed below. It is the highest value minus the lowest value. Next we have is the sample variance. Now, I want to indicate that the purpose of finding a sample variance is to actually find the standard deviation. But the sample variance for a data set is an approximate average of the square of the distance between each data value and the mean. Once again, the main purpose of the variance is really used for the standard deviation, which is the most important of the three types of measures for variation. Now, the formula that you may see associated with the sample variance is the one that is listed down here. And the sample variance is known as S squared. S squared equals to the sum of the square of the difference between each data value and the mean. Then you're going to divide that by the sample size minus 1. So the first thing is first, you must find the mean of the data set. Then after you find the average, subtract the average from every value in the data set. Whether it's negative or positive, you will then square those deviations, those subtractions from subtracting the mean from the data set. After you square those values, you will add it up and you will divide that sum by the sample size minus 1. It may sound complicated, but it's actually not that bad. In this course, we're going to be using the shortcut version, the shortcut sample variance formula. So the main thing is we have to find the sum of our data, and then to find the sum of the squares for our data, which we're going to see in a few minutes, and divided by n times n minus 1. N is the sample size, how many data values in my data set. And in this course, we'll also use the shortcut sample standard deviation formula. And the standard deviation is the square root of the variance. Square root of variance. So once you find the variance, apply the square root, and that is your standard deviation. Now, the standard deviation provides an approximate average of the distance between the data values and the means. So it's not the square of the average distance, but it's the average distance between the mean and the data values in the data set. And this right here, the sample standard deviation, is the most important. The smaller that number is, the more consistent the data set is with the mean, And if the mean, median, and mode are the same, that means the more consistent the data set is as a whole. So, enough of me talking about that. Let's get into the problems. And we find out which data set is most consistent by finding the range, the variance, and the standard deviation. Let's go ahead and do that. Let's find the range for the first data set. The range is the highest value minus the lowest value. H for high, L for low. The largest data value in this data set appears to be 50. And the smallest value in the data set seems to be 25. So when I compute my range, that is going to be 50 minus 25. And that equals to 25. So my data ranges 25 units in total. Okay. Now the range only lets you know how far the data set is as a whole, but it does not examine the values within the data set. That is why we need to find the variance in order to find the sample standard deviation. Now, I'm going to write the standard deviation formula over here, the one that we're using. Now, don't confuse the sum of the squares of your data with the sum of your data squared. Those are two different things. Let's create some sort of table as well. You know me, I like my tables. The first column is going to be x. So rather, the first row is going to be x, the second row is going to be x squared. Now, let's place our data values in each slot. 25, 30, 45, 40, 35, and then 50. And at the ends of my data set, I want to place for the first row the sum of my data, and then the sum of the squares for my data value. Okay. Let's add up those values. 25 plus 30 plus 45 plus 40 plus 35 plus 50. That equals to 225. Now, if you notice in my formula, it says right here, it's the sum of my datas being squared. So what I'm going to do is, to find the sum of my datas being squared, we're going to square 225. So square your 225. And 225 squared is going to equal to 50,625. Okay. I thought I can close it out more, but I couldn't. So do that off the back so you do not confuse the sum of your data, the sum of the squares for your data values. Now, for the next one, we first have to square each data value and then add it. So if x is 25, this here is 25 squared. 25 squared is 625. If x is 30, this is 30 squared, and that is going to be 900. If x is 45, this is 45 squared, which means that's going to be 2025. If x is 40, this is 40 squared, which is 1600. If x is 35, this is 35 squared, which is 1225. If x is 50, this is 50 squared, and that's going to be 2500. Once you square the data values, add those values together to get the sum of your squares for your data values. So 625 plus 900 plus 2025 plus 1600 plus 1225 plus 2500. We add that up, we receive 8875. Now, let's find our sample variance. We're going to use the formula. So let's close the calculator for a second. Now, to find my sample variance, s squared is equal to n. And remember, n is the sample size. In my data set, I have 6 data values. So n is going to be 6. So 6 times, this says the sum of the squares from my data values, which is going to be 8,875, minus the sum of my data values being squared. When we did that, we got 50,625 divided by n times n minus 1. Let's compute. 8 times 8,875. Excuse me, my apologies. 6 times. Got to be careful right there. That is 6 times 8,875. That equals to 53,250 minus that value, 50,625. That is going to equal to 2,625. Now for my denominator, which I should have done, n is 6. So that's 6 times 6 minus 1. That is 6 times 5. 6 times 5 is 30. Let's divide that by 30. That is going to equal to 87.5. That is the variance. To find the standard deviation, that is equal to the square root of the variance. So the square root of 87.5, let's go ahead and do that. Let's take the square root of that. So second, x squared, 87.5. Let's round to 2 numbers after the decimal in this case. My standard deviation is 9.35 approximately. And that is how we find our range, our variance, and our standard deviation. All right, guys, hope that made sense. Hope you enjoyed the video. And the next question for the next video, I'm going to do the same thing, except I'm going to move a little bit faster. I'll see you soon. Take care.